Welcome back to day 76 of Daily LeetCode. We are still on our Majin Vegeta character arc. We are back once again to reflect on yesterday's day. Yesterday we did the first weekly contest we ever tried. It was weekly 308, but we missed it. So it was the virtual contest. Not gonna lie, we kind of fried, but hey, it is what it is. We got fried, we did some frying, and we also got baked. We got cooked by minimum amount of time to collect garbage. In the end, I think we just ran out of brain juice, right? Because, like I said before, we do some reading beforehand. Before the LeetCode, I do some reading and some other stuff, and then some Codecademy and just other like learning stuff. So I think at the time we had gotten to this, and after solving, I think 2 or 3 problems, we just ran out of brain juice. So either we should. Usually what happens is we come back the next day and we can solve the problem much quicker, but we have to get back to the grind. I think we actually have quite a few problems set up that we still haven't done. So we should be able to do these in Ruby, and so that'll be the goal, and then we'll get back to the weighted problems. But yeah, so yeah, I think that's all there is. And the other thing I was reading about some system design today. There's also a cool website called Highly Scalable, right? And it's just, I think, a bunch of system design, right? But it's been scaled, or they're blogs from top engineering or tech companies, right? They have a bunch of blog posts. Someone has gone forward and pretty much summarized it into a post, right? And it's by people who know how to write, like they know how to break down the concepts, right? Funnel it into like digestible gems that you can take away. So reading that, and then they have a references section below the article, which you can then go and read the actual articles they sourced the summarized article from. So yeah, you're going to want to check that out. Some legendary resources. It's a secret website URL is actually hosted in the Discord, so you won't be able to find the website unless you join the Discord. So a necessary evil. So yeah, that was pretty cool. So we were reading about that, and the one I was reading about was actually Tinder. So it's pretty interesting to see how Tinder does like geographical sharding, but I won't bore you with the details. That being said, system design is pretty dope. So we're gonna have system design again in the title today. But yeah, I think as another angle for something we probably should learn, we're reading a lot about system design. There's something to be said about application as well. So maybe we should actually go ahead and start messing with some system design resources. Like maybe we should be poking around in AWS or GCP or Elasticsearch, all these other tools like SQS and Dynamo and S3. I think we'll get there eventually. Slowly we add more 30-minute blocks for more things to do. So ideally, I'm also thinking I'd like to add a 30-minute block for front-end work. So I want to balance out. So yeah, there's just a lot to be done. So that'd be really cool if we could do back-end, front-end, system design, and LeetCode. I think we'd cover a lot of bases. And then we'd add one more block for personal projects, and then I think we'd be pretty set. So yeah, that being said, it'll be interesting to see. I was also thinking maybe we'll bring down the time, right? The timeshare. This is a time sharing investment. There are some time sharing investments available in the Discord that are very ethical that you're going to want to join and get a share of. But I'm thinking about maybe we'll bring it down to 30 minutes. Thomas mentioned this the other day, but there is 30 minutes enough for daily LeetCode, right? Sometimes you have to go slow to go fast. So I think just by always making progress with 30 minutes, we're going to get where we need to go. Also, there are other things, right? I think there's also like a thing that I do where I think, like LeetCode is everything, but we're also, I think someone on Hacker News said this, but people pay us or you or people to solve problems. So we have to be able to use like other tools like AWS and Angular and React or Rails or all these other things, right? So we need to be able to solve problems. And so I guess that would be part of the reason I would shift the 45 minutes to 30. Then we could have other things come into the play as well. I'm not gonna lie, there's also another channel on the internet that I run that has secret game dev updates, right? Hidden from this channel, but there are other things at play. So yeah, it'd be really cool to be able to work on some of that stuff as well. But trying to become as well-rounded as possible. So 30 minutes may be a necessary evil, but even so, even this is the crazy part, 365 days in a year, even if we do 30 minutes or 20 minutes a day, right, over a year, that's still like 162 hours. So that's a ridiculous amount of time, right? And additionally, right, it compounding over time is pretty cool, right? Because we'll be consistently revisiting the material. So we shall see. I think we're going to do 30 today because I think we just finished doing some Codecademy, which is what I was doing just now. And there's still more. Then I want to get to this Rails course. Yeah, there's just so much. This LeetCode challenge is just very interesting because we're able to learn so much. And now I'm getting excited about other stuff we could learn. But also, we have to shout out Ivan Jurek on day 1000. Actually, this is what the video title is going to be. Yesterday, Ivan Jurek, the legendary squat god himself, philosopher, and part-time author, dropped Squat Every Day 1000. And yeah, the reflections on that video is just incredible. The work ethic, the dude is an incredible human. So, I mean, he's part of the reason this channel started. So, I'm going to put a link to his video in the description. But yeah, legendary human, maybe we can get to 1000. And then maybe there will be a role switch where I'll squat and then he'll do LeetCode. But we'll see. Maybe that'll be a special for day 1000 on this channel. But that's the case. So I think we're going to just jump into it for day 30, right? But at the same time, you're going to want to join the HCC, the Hyperbolic Coding Coalition, or Chamber. We have secret links like the link to the website hyperscalability.com, as well as links to quaster.com, as well as other popular learning websites that you're going to want to have access to expedite your learning process. So make sure to join the Discord. We're also going to have some special guest appearances by an artist that will be announced at the end of the week. But this person has 2 trillion streams, so there's not that many people that have that many streams. So you're going to want to be in the Discord, right, when that happens. So we're going to jump into it, and there's going to be 30 minutes on the clock. I'm just going to jump into the cards we have remaining. I'm going to kind of hopefully push these bottom ones back. We might blow through all these cards. I don't really know how to do. I got to talk slower. I don't really know how to use Ruby classes yet, so more to be done. We're going to jump in with valid palindrome with 30 minutes, and let's see how far we get. I'm going to make my cam smaller to make this less uncomfortable for anyone watching. And then we're just going to jump into it. So we have valid palindrome. A phrase is a palindrome if, right, after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backwards. Alphanumeric characters include letters and numbers. So given a string S, return true if it is a palindrome or false otherwise. So we do have this palindrome with an S. We're returning a Boolean. It seems like what they really want us to do, right, given a string S, like a man, a plan, a canal, colon, Panama, right down here, they want us to convert all uppercase into lowercase and remove all non-alphanumeric characters, right? And if it reads the same forwards and backwards. So you can, there is a version of this, right? There are a couple of cases you could go. An unoptimized route, right, could be that given a string like a man, a plan, a canal, Panama, right, you could do a linear time iteration, right, clean the string, right? This would be linear time and space, right, to clean the string. What you would do is you turn every character into lowercase, remove spaces, colons, pretty much everything non-alphanumeric, right? And then from there, you could just iterate from both sides of string and check character matching and check car matching, right? So we can just quickly, we can imagine how that would work, right? If we just paste this string here, right? Well, let's clean the string, right? We'll turn everything into lowercase, right? Now we're going to remove everything non-alphanumeric, so that's spaces, commas, spaces, comma, space, space, colon, colon, right? Now if we start from the front and the back, right? Does A match A? Yes. Does M match M? Yes. Does A match A? And so on, right? Until we get to the middle and they pass each other, right? Then we'll know that they are a palindrome, right? But one way we could optimize this, what if we did the cleaning and the checking at the same time, right? So what we could do is we could have 2 pointers, just like as we're checking from left to right to the center, except what we'll do is we'll just skip invalid characters, right? So A is still a valid character, right? Because it's alphanumeric, so we'll check A and A. We'll just make sure we push both of them to lowercase right before we compare them. Right now, if we look at the right pointer, we can compare M, right? But if we look at our left pointer, if we add 1 to it, we compare space. So what we're going to see is we're going to have to find the next valid character. The next alphanumeric character is going to be M. So they're not going to be parallel in terms of their distance from their origin, but they're going to be parallel in the sense that both pointers are going to refer to a character that is valid. So typically we do this with regex, so maybe we can come up with a version. Maybe we can come up with a way to know if a string is alphanumeric without regex. So if that's the case, we just have to iterate from both sides of the string and check the characters matching. Before we can iterate from both sides of the string, we have to check if the string can be empty. Well, the string can't be empty and it's going to have at least 1 character. So we should be good. So to start, we're going to need a left pointer, which is going to start at 0, a right pointer, which is going to start at s.length minus 1, because the last element in a string or an array is always going to be the length minus 1 because of 0 indexing. And then we're going to say while left is less than right, do. Then we're going to have end, right? So what do we want to do? We want to make sure first that we have valid characters for where we currently are. And to do that, we're going to have another loop, right? We're going to say while left is less than right, and, right, we're going to want to make sure that s sub left is alphanumeric, right? So maybe we can define a function, right? We'll say is alpha num, it's going to take s, right? And then it's going to return true or false, right? So let's just say if s, right? How can we tell if our string is alphanumeric? We could check its character code. And I think if it's within a certain range, it has to be alphanumeric, right? But we have to check that, so let's see. So based on this chart, we can see that pretty much it says characters 32 of the standard implementation independent alphanumeric characters. That's definitely not true. I think the range we're actually going to want to work with is 48 to oh, right. The range we're going to want to work with, it seems to be the range 30, oh, no. Ending at 122, right? 48 to 122. So that's just what we're going to do. And then we'll need to check if we can find the car. So we should be good. I think we know we can use the range 42. I think what did we just check, right? 48, right? Starting at 0. So 48, right? Up to 48 up to 122, right? So 48 up to 122. So we say 48 to 122, right? So how do we get the character code in Ruby? We'll just say car code is equal to s.ord, right? And we'll say if and we'll just shorten it to code. If code is greater than or equal to 48, and code is less than or equal to 122, we don't need any braces because it's Ruby. We're going to return true, and then we're going to do end return false. So now we have is alpha num, right? So now we're trying to validate a particular character. We can just do that. We can just say, well, while left is less than right, and s sub left, right, is not alphanumeric, right? What are we going to want to do? We're going to want to say left plus equal 1, right? And then do end. And then we're going to do the same exact thing for right, right? Except right increments, right, by decrementing, right? Its progress step is going to be decrementing, so it's going to the center. So we can do that here. And we're going to want to make sure we pass in right. Then we'll say, now we can do the checking, right? If s sub left, right, dot down case does not equal s sub right, dot down case, right, return false. Right, and if we make it to the end, then we can return true. So let's try this for our base case. So on line 5, we have a problem. Oh, we left our range here. Oh, and we missed one. Why? So I always make sure to check our assumptions. We missed one final thing. We need a regular progress step as well, so that we don't end up in an infinite loop, right? And that's going to be right minus equal 1. So let's just make sure it makes sense. We'll start at A and A here, right? 0 is going to be less than, let's just say 30, right? And left is less than right, and A is alphanumeric, so we don't actually have to do anything here. A on this end is also alphanumeric, so we don't have to do anything. If we downcase both of them, they're equal. So we don't have to do anything, and then we'll add for both. So I think we might be good here. So now we return false. So I wonder why that would be the case. So one way to check, right, is just to make certain that we're shifting our range correctly, right? So one way to do that is just, we can just print s sub left, right, and s sub right. I think so. I see. So it's this last colon that's giving us trouble. Why is that? You said 122. So we said 48. Right? This list is, oh, wait, no. It's definitely not 48, 49. Right? And we don't want to include these characters. Right? So actually, the range here is just a little strange. So we actually want to filter out everything. So we probably just say 48, right, to 48 to 71, right, 48 to 71, and then 61 to 101. So if code right, and then we're going to want to say, what was it, 48 to, no, it's 48 to 57, right? So we'll just say that 48 to 57, right? Or maybe you actually don't need, and then we'll include the range for the letters, right? And that should be A starts, I think lowercase a starts at 64, but we keep having to look back. Capital A starts at 65. So capital A, right? So pretty much 65 ending at 122. To 65 and code is less than or equal to 122 and return true. So it seems to work in that case, right? And then we'll change our test case, right, to some of these other test cases just to make it make sense. So let's try it. I wonder if we're still including 48, 57. Yeah, this is definitely easier with regex because now we're just doing 122. And then we have 48 to 57. So we should be good, actually. So I'd be curious to see why this one is failing. So left, we're at A, right? And then A and A are good. Now you want to find the next valid, right? For the next left, we find B, but for right, while left is less than right, which it is, S sub right. Wait, okay, so left starts at 0, right starts at 0, 1, 2, 3, right? 0 is less than 3. Both of these are alphanumeric, so we don't do any work here, right? We downcase them, they match, we continue. Left is now 1, right is now 2. 1 is less than 2. 1 is alphanumeric, so we don't do anything. Right is not alphanumeric. So we should do right minus equal 1. Oh, left. Right, because now they're the same. No, they're not the same. If we start at 0, and this one's 3, we move this one left. Let's just restart. Left starts at 0, which is A. Right starts at this, which is 3. Right, they're both alphanumeric, so there's no need to do any work here. Then we do puts, right? So we print, right, A and A. Down case, they're the same. Now left is equal to B and right is equal to underscore, right? Left is less than right and left is not alphanumeric. I think I might see the problem here. This should only give us a problem if we're considering if underscore is alphanumeric. So if I do puts is alpha num and we get true, I'm using JavaScript quotes. Right, so this is the problem, right? True underscore is not true. This is from Microsoft. So I think, and this is beginning Perl. So I'm just going to look up how we can check if something is alphanumeric in Ruby. So I just learned how to use regex. So typically when we do this one in JavaScript, we do it with regex. So I didn't know how to use regex in Ruby yet. It looks like you can just literally do string.match. So we can pretty much remove all this code and just return s.match. All right, we want A to Z, and 0 through 9. And we want at least 1. And this should return truthy. Wow, this is really slow. Yeah, I wonder if it'd be faster if we literally, well, there is a way we could do it if we just populated a hash with literally all the alphanumeric values. Let's say something like this. And then we could say like A, or I think it's like this, A, right, to Z dot each do, we'll say car, and then we could say hash sub car. And the default value would be false. So we'll set hash sub car equal to true, right? And that's what we would have for both of these. And we probably just can't have this code sticking out, so we'll probably just have this in our function is palindrome. And I'll minimize this block. It's kind of hard to see. Oh, we actually have 2 of them, right? And then we can do the same for 0, right? And we actually want to include Z, want to include 9. And then we'll say hash sub num equals true. And then we'll just change this to hash sub s sub left. But what we're actually going to set in the hash is going to be a string of the number. And then when we check if it's, we can just say if it's in the hash, right, then it is alphanumeric. And yeah, this was a function, so we're going to want to change these to brackets, of course. Oh, for the strings, yeah, for the strings we have to add, I always forget, for the strings we have to add both, right? So we'll say dot upcase also equals true. This is faster, but I think ultimately, yeah, the regex version, a little bit slow, but constant, it would be constant space for the hash, since we can guarantee it's going to have the sum of the number of numbers, right, and alphanumeric characters, which should be 26 times 2, which is 52, plus 10 symbols, which should be 72, which could be hard-coded. It takes constant time to look that up into the hash. function or amortized constant time. So I would say the time complexity, this would be linear time and constant space. That was interesting, learning to use regex. So interesting. +1 is always a good problem. I don't know if we can do it in 6 minutes. You're given a large integer represented as an integer array digits. Each digits sub I is the ith digit of the integer. Digits are ordered from most significant to least significant in left to right order. The large integer does not contain any leading zeros. Increment the large integer by 1 and return the resulting array of digits. So to map this problem statement to our example, in a large integer represented as an integer array digits, so large integer being 123, the digits of I is the ith digit of the integer, right? Digits are ordered from most significant to least significant, right? Pretty much like a standard number is written. It doesn't contain any leading zeros. They want us to increment the large integer by 1 and return the resulting array of digits. So 123 here represents 123. They want us to add 1, change it to 124. 4321, add 1, change it to 4322, right? But this is the edge cases, right? When you add 1 to 9, you actually get 10. So you should actually push in 1 onto the front, right? And the special part about this is why it's stored as an array. It's because we can have digits of length up to 100, which means depending on the language or the environment, we might not have a, or actually, we might need a special type of object which can do addition on numbers that have up to 100 digits. Fortunately, we can use a solution which incorporates elementary addition, right? So when you want to add 121 to 123, right, you would start from the back, right, and you would add 1 to the number here, right, and then you'd increment that by 1 and return 1, 2, and 4, right? When you have a number ending in 9, you add 1 onto the end, right, and then that number actually becomes 0, right, and then you carry the 1, and then you actually have 3, right, and then you get 130. You can actually abstract this out as an algorithm which adds 1 to a number, but in reverse. Right, and there's also another problem on LeetCode that is similar to this with a linked list, and it has a similar intuition, right? So the algorithm, that the way this works is, what you would basically do is you would basically turn, since you're only adding one number, right, we get the benefit of only actually having to, we can simplify the algorithm, right? If we were adding a bunch of numbers like 111, it would get complicated, right? But since we're only adding 1, all we have to do, right, is check if we iterate from the array in reverse, check if our number is 9. If it's 9, we change it to 0 and we go to the next number, right? 2. If it's 9, we change it to 0 and go to the next number. But if it's non-9, we add 1 and we can return it, right? But there's an edge case here. If we have a bunch of 9s, we actually never add 1 because it's non-9, right? The way we exit is through there being a non-9 number. So if that's the case, right, we have an edge case where we're going to have to shift. Oh, we would have turned all these 9s to 0s, right? Then we'll have an edge case where we actually have to add a 1 to the front to make the number make sense. And we can demonstrate that, right? We say iterate in reverse, right? And then we'll say, actually, my Vim is not working. We'll say if 9 set to 0, else add 1, return. Edge case, all zeros, shift 1, or unshift 1. So what we can do is iterate in reverse. So what we'll say is digits.length minus 1, right, going up to and including 0, each do I, right? And what we're going to do, like we said, right, if digits sub I equal 9, right, then we're going to want to say digits of I equals 0, right, and then go to the next iteration. Otherwise, right, we actually want to do is digits sub I equals digits sub I, right, and then add 1 to the value actually stored at that index. Then we can return digits, right? Then we can actually end that loop, right? But if we imagine this algorithm, right, running for something like 999, we're going to start at digits of length minus 1, which is 3 minus 1, which is index 2, right? Digits sub 2 equals 9. If it equals 9, we change it to 0, right? Then we decrement, change this to 0, right? Decrement, change this to 0, right? But now you see we have all zeros remaining. So our edge case is going to be all zeros. If we didn't exit up here, right, and we know that our output has all zeros, so we're going to do, right, is we're going to say digits unshift 1 turn digits, and we'll check. We just check that that made sense. Okay, so our input is 1 2 3. We end up returning 1 1 2 3. So digits.length minus 1, right? So we're starting in reverse. Digits of I equals 9, digits of I equals 0. Otherwise, digits of I equals digits of I plus 1, then return digits. But I'm actually curious why we didn't return here. So we're actually going to do puts digits of I. Maybe it's a Ruby thing. Right, so we're actually not even exiting here. Oh, right, so we're trying to iterate in reverse, right, but this is not running. We're just adding 1 to the front and then returning digits. So it might just be easier to say I is equal to digits.length minus 1. Then we'll say while I is greater than or equal to 0, going to I minus equal 1. I think we do need a do here. I'm still in JavaScript mode. So, right, it was just a misunderstanding on how the loop works. So this would be linear time, right? But in the worst case, linear space, depending on if we include our output. But we'd have to add a 1 to the front, right? Which in the worst case would actually give us 2n runtime, and we'd allocate up to n space to add this one number. So that's a wrap.